Hello, ladies and gentlemen. My name is Kurt, and welcome back to Space Engine. As promised, I mentioned in an episode of Far Lands or Bust that I would discuss some of the recent astronomy and space news, but also take a look at a incrementally updated version of Space Engine. As you can see in the lower right-hand corner, we're in version 0.9.7.1. The previous version we used was just 0.9.7. So an incremental update, and there's actually been a few pretty noticeable updates. The first of which you might notice in the background, there's music happening in the background. It's a very cool. Actually, let me go back to the options and show you. In settings, there is now a sound. There are sound effects. I don't know what sound effects there are, but there's music, and there is contextual playing. That means the music changes and switches tempos based on where you are, if you're traveling, if you're above a planet, or above a nebula, or traveling between galaxies. It's kind of cool. I'm hoping it's all legit and okay with the Content ID system on YouTube, because I don't need any more problems with that. But it's a very cool ambient, kind of gives a little bit more of a zen approach to traveling throughout the universe. As you can hear, the music just kind of changed as I came in here to the planetarium. We are high above the old planet Earth, and we're going to take a look at a few things within the solar system here, but also outside the galaxy itself in Space Engine. But what was I going to say? I was going to say something about Space Engine. Oh yeah, Space Engine! Go to spaceengine.org. Oh, that's cool. Let's see, the moon is kind of backlit by the galaxy there. Go to Space Engine, the website. There's a link in the video description below. This is a universe simulator with procedurally generated stuff outside of what our knowledge consists of within the galaxy, but it's been and continues to be developed by one person. And they are currently fundraising to continue the development, and they have different milestones. If they raise this amount, then they'll add these features. If there's really long stretch goals that he's saying if he raises a certain amount of money, he wants to turn it into an actual game that you can fly around and have realistic physics, much like a very advanced Kerbal Space Program, I suppose you could look at it. So, right now they've raised just under, or just around $10,000, which you can go and check that out. I've certainly given, because they've provided me, this program has provided me with quite an amount of content to put up on my YouTube channel to show you guys some astronomy, science, spacey stuff, which is really quite awesome. So continue to support not only your local YouTubers, but your local independent games and software developers who, it still boggles the mind that one person has created all of this. I know there's been help, and there's even, he's adding, and there's a little bit of a small library of user-made add-ons that add extra textures or different spacecraft if you want, or sci-fi stuff. That's very cool, so you can check that out all at the website and in the forums. But we're here outside of Earth, as I said. I'm going to zoom out so that we can see pretty much the entire solar system, turn on the orbits of the planets, and get ourselves on a face-down plane. Obviously, that's Earth, Venus, Mercury, Mars is on the outside. Then we got Jupiter with all the Jupiter's right there. Sorry, I forget that you can't see my cursor, I don't think. Fraps, for some reason, doesn't record the cursor in Space Engine. Jupiter, we got Saturn, and then out and further out. But what I really want to look at, I'm going to zoom in between the orbits of Mars and Jupiter, as you may know, is what's commonly known as the asteroid belt. And this guy, Ceres, I talked about in Far Lands or Bust. Ceres, with recent data taken from the Herschel Space Observatory, which actually ran out of fuel and was decommissioned in April 2013. but there's still a just database of information and data and science gathered by the telescope that only recently it's been released that scientists discovered that there has been water vapor emissions coming from Ceres, just beyond the orbit of Mars. Ceres is a dwarf planet. Let's go to Ceres here. So water vapor emissions coming from the surface, very similar to what happens on the ice moons of Jupiter and Saturn. Enceladus and Europa have, you know, ice volcanoes, water volcanoes, almost like geysers. They spew water, H2O. Sometimes it obviously freezes right away in the deepness of space, but, you know, it means there's liquid water somewhere under the surface. And this, in Space Engine, is just an approximation of what Ceres looks like. We have just very blurry, low-resolution images you can look up on the Googles of Ceres from Hubble Space Telescope, and it is very cool because there is a feature that they notice on Ceres as it rotates on its axis. There's a very bright spot, which obviously, now that we know that there's water vapor coming, it could be obviously an ice, a pole, perhaps some sort of ice cap. Very, very interesting to find out, and we are going to find out. And I'm assuming Space Engine is going to be updated once the Dawn spacecraft arrives at Ceres in February 2015. So a little bit over a year from now, we are going to have a NASA satellite visit and orbit and study and map Ceres, and perhaps now with this newfound information about water vapor emissions, it could be a very tempting target for future exploration and perhaps landings. You know, it's a little bit closer and easier to get to than the moons of Jupiter, which are also, you know, the planetary scientists are really gunning for funding in order to send some sort of lander or probe to Europa or Enceladus, or those very prime planetary, well, not planetary, I suppose, just prime bodies for but the potential for extraterrestrial life. Little microbial life could be living in this under surface ocean that could potentially exist on those moons, and now possibly, being as this is just new information, possibly on Ceres. So very interesting. And like I said, it's way out here in the asteroid belt, and as you saw, it's not the asteroid belt, I believe, probably from movies and sci-fi. You tend to think it's like this big cloud of giant boulders that would be very dangerous to fly through. In all honesty, there's a whole lot of emptiness out there. You'd be hard pressed to just fly through the asteroid belt space, you know, like at this level, and actually run into anything. And that's why even, you know, spacecraft like Juno, which is currently headed out to Jupiter, they don't even take that into account. When Juno is on its way past the orbit of Mars and towards Jupiter, they don't even take into account the possibility that they might run into something out there, just because the possibility is nearly zero. Obviously, they track things like they don't want to run into Ceres or even Vesta. Let me look up Vesta. Vesta is another large asteroid. As you can see, this is current time right now, very close to Ceres, and the Dawn spacecraft actually was orbiting Vesta for quite a while and left Vesta, and because they're so close together, the orbits are putting up for a nice conjunction, which is why this is when they sent the Dawn spacecraft out there, because it can explore both Vesta and now heading out to Ceres. So very cool stuff. Let's go into Vesta, and we're going to take a comparison. The reason Ceres is a dwarf planet is because it has that characteristic where there's so much mass there that the gravity has actually... Oh, there's a word for it. Gravitational something or other, where it's actually the shape of a sphere, much like a planet, as opposed to a smaller object, still quite large, but a smaller object like this doesn't have enough gravity that it's somewhat spherical, but it's not... It's still a lumpy potato, if you will. The old lumpy potato. So that's very cool news. And again, really looking forward to 2015. As I've always said, is going to be a big year for science and space and planetary science. It's also later in the year is when New Horizons is going to make it to the other dwarf planet, Pluto. which is, by comparison, way out there. And we're going to get our first close-up images of Pluto. We have, I think, obviously much closer. The pictures we have of Ceres are much higher resolution. I don't know, like 30 pixels as opposed to like the 3 pixels we have of Pluto from Hubble. And of course, here we go towards Pluto. And again, an estimation, a visual estimation of what Pluto might look like, just based on some random textures taken from here in Space Engine. Of course, have they found? I think Ceres, they say because of this water vapor that it does have a very thin, tenuous atmosphere. And I think they've said the same thing about Pluto, which is why here we're seeing a little bit of a glow, that there could be a very slight, barely existing atmosphere here on Pluto. And actually, let me do something really cool here. The visuals here in Space Engine are exaggerated, both for dramatic effect, but also just so you can actually see features on Pluto, and that's Charon. It's kind of a dual-bodied system. If I go into the options, where are they at? On the left side. Hello, options. There they are. Come back. If I go into the options, and I can turn on the real planet brightness, that's actually how dim things are out here at the far reaches of our solar system, and why it's very difficult to see Pluto. I think, gosh, I want to say I attempted to see Pluto with my telescope, which is an 8-inch Dobsonian reflector telescope. I can't remember if I was able to do that or not. It was recently like near another planet in the sky, and it was kind of easy to find. I don't know if I saw it with my telescope, but a friend in the astronomy club has an 18-inch home-built Dobsonian, huge, just massive thing, and that's the diameter of the objective lens, or mirror in this case, and I think we were able to see it through there, and it's very dim. Obviously, the Milky Way isn't that bright at this distance, but a very dim object. And you also saw there was said to be a potential problem with New Horizons is because they've been finding all of these other objects that are orbiting Pluto and Charon, and there's quite many of these other, I suppose, moons orbiting the Pluto system that then they were kind of worried about. They might have had to adjust the New Horizons path to not get as close to Pluto as they would like to avoid all these, and potentially ones we haven't seen yet, of these moons. But I'm not sure if they've made a decision on that or not. They still have a couple years until the New Horizons spacecraft comes way out here towards Pluto. So very cool stuff indeed. Let me turn the planet brightness back up just because I know... Oh, also, yeah, that's another thing. Let's turn back around. If I turn off all like the diffraction spikes and stuff, the stars and the sun becomes much less dim. But let me turn that back up so now dramatic space effects. We can actually see what we're looking at. So yeah, like I was saying, Ceres, dwarf planets, very interesting stuff happening in the coming year. But also, let me go back to Earth. Earth, just so we can get a reference on things. Yoink! We'll also see how much brighter the sun is from this distance versus way out here 33 times further away at Pluto. We're going to talk about Supernova. I mentioned on the 21st, last Tuesday, Supernova in M82, the Cigar galaxy, was discovered. That's 12 million light years away. So actually it happened 12 million years ago, but we're just now seeing the light. So that's very exciting. It's going to remain bright, and it's gradually getting brighter, well within the range of your amateur telescopes. Magnitude 8, 7, or actually, no, I'm sorry. I was thinking of Ceres as magnitude 8 or 7, but the Supernova is about magnitude 11, and it's going to continue to get a little bit brighter. Not visual to the naked eye or anything, you'll need a telescope, but I'm going to look up M82, the galaxy. I'm going to select it, and from Earth, or from the orbit of Earth, It's only visible from the northern hemisphere, but it is there. I wonder, is there a way I can turn on the constellation lines? I thought there was. Hold on, I'm looking through the options here. Constellation lines. Let's see. Orbits, vectors, victors, equatorial grid. Well, there's the North Pole. So it's about there. It's very difficult because the way this software over-brightens certain stars, I'm having trouble picking out any of the... what am I looking for? Labels? No. Oh gosh. Any of the constellations. I thought there was an option to enable that, which is really cool because when you fly through the constellations, they change because we're all looking at them from a different perspective. Please wait while this awesome, chill music serenades you to sleep. What was that one? Oh, come back. Star browser, no. Spacecraft. Journey log. Locations. Dang it. Yeah, okay, well I must have forgotten. C? No. L. Oh, no, that's the time. Let's go back to normal time. Alright, anyway, I forgot how to look at the constellations. I apologize. But M82 is way out there. As you can see, it is 3.710 megaparsecs, which is actually 12 million light years, as I said. And we're going to travel there. Right. Oh, yeah, that's right. Oh, here we are. I'm sorry, I just see it right now. Here is the handle and the dip of the Big Dipper. And I lost it. M82 is you kind of follow the dip, the side of the dip part, the spoon part, I suppose, of the Big Dipper. Follow these two in an upwards direction, and M82 is kind of off and to the right of that direction. Star hopping was never my greatest skill in astronomy, but while we have it, let's head there, out of our Milky Way galaxy, and the background galaxies. Galaxy craziness. They brighten up. We're gonna head out here. And I love how Space Engine displays M82, the Cigar galaxy, because it is an irregular galaxy. It doesn't have a spiral shape. It doesn't have any sort of specific structure because there's a lot of very young and new stars forming. So it's a very young galaxy where a lot of these solar winds are actually spreading out. All of this, you can't see it in this representation, but there's a lot of dust and gas expanding out from the center, and that's why it's kind of called the Cigar Galaxy. Very cool. Of course, also, Space Engine doesn't update with weekly, up-to-the-date information about supernova and things like that, so the supernova isn't here in Space Engine, but it's a little bit out from, it's say, about there, if we're looking at the galaxy like this. Oh, oops, I actually selected a background galaxy, but let's say it's about right there, and, looking at images from the week before, there's nothing there, and then looking at images now, there's a very bright light there, so it's definitely a supernova, and they're studying it, and it's very cool. We can actually, even though we are 12 million light years away from our galaxy, the way Space Engine works is it's going to procedurally generate all the stars within M82, and we could actually, say, visit one. I'm looking for one that might look like a red giant, which would go supernova. Who are you? You are a blue main sequence star. A yellow dwarf, like our sun. There's a binary yellow dwarf. Orange dwarf, getting close. White main sequence star. Actually, our star is a white main sequence star, is it not? Oh, what's this one? Orange dwarf. I'm not finding any red giants or anything. Although actually this is a type 1A supernova, so it would actually be a white dwarf and a red giant next to each other. Okay, let's go to a binary system just because that's what this kind of is. It's very cool Ooh, we're passing through. There's a lot of dark dust preventing us from seeing the innards of this galaxy. Innards! Heyo! Here's a very cool binary star system, and I'm going to assume that it has planets. Oh, it does not. That's unusual. Well, I suppose... No planets. Okay, ooh, no planets around this system, and it looks like... Let's go. This is a weird star. It seems like the gravitational pull, or maybe the speed at which it's spinning is causing it to be oblong. I suppose I personally have done no research on that fact, but apparently we have some oblong stars. It makes sense. The Earth is actually kind of squished like an oblong egg because of the way it spins on its axis, so... I suppose if a star spins fast enough, it would kind of shrink out like an egg shape there. Very cool. But yeah, we're like just flying around now. M82, which is very cool. Yellow dwarf. Orange dwarf. What does an orange dwarf look like? We're doing science! We are explorers of a distant galaxy. And we have our iPod on shuffle, apparently. Ah, there we go. This one's got a bunch of planets. And it's also a binary system. But yeah, supernova are cool. Whoa, whoa, whoa. Slow down there, spacecraft. Supernova are cool. Oh, this is cool. The binary system has planets orbiting it. Its, you know, gravitational center, but then the stars themselves have their own planets orbiting them. Not too shabby. Let's see what we got. Frozen ice world, that makes sense. Then what kind of stars have you got? You've got some hot deserts, a warm ice giant, cool gas giant. You can always see if there's life on any of the moons of these planets. Too warm, I believe, here. How about off in the distance? What are you? Oh, no, come back. Go back. Yeah. Okay. Now what? Planets. How do I select these planets? I'm searching! What are you? Huh, I'm like selecting these planets, but I can't find out what they are. Okay. Whoops. Zoom! Ha! Ah! So much. Too many planets. Alright, let's just visit one of these planets, why don't we? It's like a Tatooine. It has two stars. The anticipation. Woo. Hey, it is almost like a Tatooine. It's like a deserty... What is that? Or, whoa. Is that... Hold on. What is that business going on? Some very serious plate tectonics? Or are those actual seams in the textures that I'm seeing? That's crazy. I've never seen that before. It's the old soccer ball planet. And what's its moon doing? A frozen ice world. Somebody's playing the cymbals. Huh, very cool. So yeah, these planets, should anybody be observing on them, would have two suns. Two suns in the sky. And we can actually, for those of you who might not have seen my earlier space engine videos, you can land on the planets. And there we go. Of course, there's no atmosphere here, but very Tatooine-y. Tatooine-y. Weenie. Alright. This is a science video, Kurt. Keep it mature. So anyway, yeah, we're in here in M82, so yeah, it's very cool that there is a supernova. Ooh. I think I am seeing some seams in the textures in the distance there. And there appears to be a nearby galaxy as well. M81, a normal galaxy. Let me look back at Earth to see what Earth looks like from here. A whole lot of nothing. Yeah, can't even see the Milky Way. Probably could, but not in this program. So let's go back to Earth. And there's actually, I've been seeing on Twitter, this is yet to be verified, but today is the 28th, Tuesday, January 2014. There's also been a possible detection of another supernova, a little bit further away, this time in, where is it? M99? Another spiral, this one's a spiral galaxy, this one's 50 million light years away, but let's actually try to find M99 and go to it. I've just seen a few images of the before and after, and there is like a brightening, but again, this has to be verified. The way science works is it needs to be double-checked, verified by other data. So yeah, M99 is far more of a traditional spiral galaxy. Without a bar, the Milky Way is a barred spiral, but, you know, supernovae are very cool things. They're the reason we exist, because without the supernova, the fusion necessary to create the heavier elements, you know, normally it's just hydrogen, and then you get helium, and oxygen, and silicon, things like that. With these great explosions come pretty intense fusion reactions that then create the heavier elements like your sulfur, your sodium, your calcium, your iron, you know, like the iron in your blood and at the core of Earth, and these materials are blasted out into space, and then they go into making new stars and planets and all this other exciting things, and that is how the, whoa, what is this? This is a crazy star. Speaking of craziness happening, that's how, anyway, that the supernova is how the heavier elements, kind of up to, I believe, up to uranium, are created. That's awesome. That's very awesome. It's like a molten lava. What kind of planets do you have? Hot deserts, temperate. That's a good word. Warm Terra. What kind of moons do you have? Temperate. Planets, hot deserts, warm asteroids. Wow, this one's got a lot. And again, this is all just procedurally generated, just kind of based on our current understanding of the likelihood of other planets and the type of stars, moons and systems they have. Wow, it's like a super Jupiter over here, and then this one. A temperate asteroid. Kind of like an Earth. It would say with life if there was life on the planet, but this looks like it could potentially harbor the potential for life. So let's check it out, and that is kind of what wraps up what I had to say. Yeah, there's like oceans and an atmosphere and very cool moons. We could, let me try to find like a cool coastline I could try to land on here. And then we could finish out this video. Oh yeah, there's now, another part of the update is there's now 3D water effects on the planets, which is just crazy. So you can see here we have like reflections, and we can go under the water as well and kind of explore. But that's very cool. We can fly around. Let's try to, whoa! Get to a coastline here. We got some mountains in the distance, I think. Or is that just a mirage? No, those are mountains. Mountains! I believe also, like the shoreline, there's waves on the shoreline, right? I'm gonna let it load up a little bit. Or I could be wrong. That might not even be liquid water. That could be some sort of liquid methane or something. And just having a lovely stroll around this planetary body. Very cool sun, kind of a purplish atmosphere. Very cool indeed. So yeah, I think, yeah, I've pretty much touched on the few things. Ceres, the supernova, and M82, showed you M82. Very cool stuff indeed. This, once again, is Space Engine. Check out the links in the video description. You can download this yourself. It's free! He's only asking for donations very recently in order to continue the... That's cool. Continue the development and, you know, make more awesome stuff like this. Oh, that's weird. The aurora, the lights on this planet are actually on its kind of side here? Am I looking at this right? Yeah, it's a little bit off center, so the magnetic pole is different from its rotational pole. There we go. Poetic ending! Indeed. A little bit scatterbrained, but I always get a little bit lost playing Space Engine, and I'm sure you will too if your computer can run it. So until the next Space Engine video, thanks so much for watching. My name is Kurt. I will see you next time.